two fundamental force fields of the universe which have shaped our solar system, and hence necessarily our planet Earth, are gravitational and electromagnetic fields. Every process of evolution, whether inanimate such as formation of our atmosphere, and the rocks under us are animate, covering all forms of life from the simplest organism, namely, amoeba, to the most specialized form, namely, man, was shaped, and intimately controlled by these two fields. The physical fields of gravitation and electromagnetism are so intimately involved in our lives, that we can hardly visualize how our entire life process would have patterned itself, if either of these were not present. From studies of spectra of starlight, astrophysicists conclude that the average magnetic field of our galaxy or universe is extremely weak, though there are about 100 stars, which have shown their own surface magnetic fields of strengths, several tens of thousands of times the surface magnetic field of Earth. The gravitational force, being always one of attraction, can be expected to compress star material into smaller and smaller confines, ultimately ending up in the so-called gravitational collapse of the universe, where the stellar matter is in such unbelievably dense packing, that conventional science fails to describe or even visualize. This catastrophe, the astrophysicists say, is averted by the opposing action of the magnetic fields of the galaxy, which try to push the material outward. Thus a reasonable balance between these two fundamental force fields maintains our universe in its present equilibrium, the magnetic field, again being the prime mover for its rotational motion with the giant spiral arms. Both gravity and electromagnetic fields are called by physicists as potential fields, implying that the force involved in these fields is mathematically derivable from a potential that is a function of position. They obey the classical inverse square law, and share many other properties in common. However, they have some fundamental differences. For example, the gravitational force between two bodies is always one of attraction, whereas the force between two simple bar magnets is one of attraction or repulsion depending on how they are placed, whether their like poles are adjacent to each other or not. The physicist calls this discriminative property of magnetism as tensor property of the field. Again, because of this property arising from bipolar nature of the magnetic field, the field intensity or field strength due to a magnetized body falls off proportionate to the cube of the separating distance from it, whereas the gravitational field intensity falls off proportionate to the square of the distance. Thus, as a deep space probe gets away from Earth into outer space, at a distance of, say, 10 Earth radii, the Earth is still pulling it back with an attractive force, but the magnetic field has already died down. In fact, at a distance of 20 Earth radii, the intensity of Earth's magnetic field drops down to 1/8000th of its surface value, which is as good as a magnetic vacuum. Again, the magnetic field of Earth is a most erratically variable field, varying both in space and time, that is, spatially and temporally, as we shall see in detail in later videos. But the gravity field changes very little in space, and still less with time, and even more important, both the changes are thoroughly predictable. For instance, the change of gravity with latitude or altitude can be predicted by calculation, with high precision. Similarly, the time changes in gravity brought about by the tidal forces, sun and moon, on the Earth's solid body and oceans can be calculated, predicted to about the same high order of precision. This is not so in the case of Earth's magnetic field, there being spatial variations in certain cases as much as the total magnetic intensity value itself or more, and time variations of size a fair fraction of the geomagnetic total intensity. Till the 50s, advent of space age, our involvement with Earth's magnetism was mostly one of scientific curiosity, by which the various manifestations of Earth's internal and external magnetic fields were studied and related with possible causes such as solar activity, geological processes and the like. However, the space age has brought about a powerful impact on our awareness of Earth's magnetism, in particular, about the possible interaction of the living body with our magnetic environment. This has generated fresh interest in the hitherto ignored ultra-weak magnetic fields generated by life processes, what is now called biomagnetism or body magnetism. These developments, all of which pertain to the last 3 decades, have given a whole new dimension to the general theme of our magnetic environment, which man has studied in surprising depth and detail, and which man has also already contaminated to an even more surprising level of pollution, all during the last, say, quarter of a century. This sufficiently merits the need for us to take a hard, searching look at this mysterious force of nature which has been at man's disposal for good or evil and is also inseparably bound to his very existence.